Yes, sir.
Oh, yes, already. Okay. So actually, we have already working with Dr. Sundar, Professor Sundar. Then our information, I already coba saya Anis co-host, jadikan co-host untuk supaya saya bisa. Ya, sudah?
Sudah.
Yes. Yeah, okay. In this case, yeah, we have published, and everybody, especially my close colleagues, already aware that we have a program that we call International Postdoctoral Program. Then, not only from Sundar, Professor Sundar sides, also I have with Swaminathan, but in different program, of course. But in here, we have 4 students as a postdoctoral research student. Yeah, the first one is Dr. Kakarala Udiastri. So welcome to our group and discussion session.
Thank you, sir.
Yes, thank you. And the second ones, I couldn't see properly because it is too, too small. Can you see, Anis? Can you see?
Fatimatul Regina.
Fatimatul.
Fatimatul, yeah.
Rajina.
Fatimatul Rajina. Yeah, I have already there. And the other is welcome to our program as well. And the other one is Dr. Rashmi. Yeah.
Thank you, sir.
Yeah, welcome to our discussion session. And then for the future scope, we will have more discussion coming. And then the last one is Dr. Sham R. Yeah, welcome, sir, to our. And I already told by Dr. Sundar that you are already working in the university and you are a lecturer. So I believe you have been taught about how to develop about scientific paper. Then our target is to submit our paper in the reputable journal, either indexed by Scopus or indexed by WOS. So I believe that's from me as a beginning, and I already told to my rector as well. It is part of our also collaboration. So again, thank you to Professor Sundar who initiate this collaboration by obtaining some student, and also now we are considering all of you as our student on postgraduate research, international postgraduate research program. We also would like to extend with Professor Sundar with Malaysia connection, with Malaysia University. And then actually I also already invite Asila as well to join, but he still have also confirmation session. And then in this case, I would like to introduce my staff. Yeah, the first one is Associate Professor Ika Hesti Agustin. He is a lecturer in the Mathematics Science Mathematical Department. Yeah. Ngomong Bu. Yeah, yeah.
Everyone,
I'm Ika Hesti Agustin from Mathematics Department, University of Jember.
Okay, that's the next researcher who is also a good programmer. Yeah, uh, Rifki Ilham Bayhaki. Please introduce yourself. Yeah.
Hello everyone. My name is Rifki Ilham Bayhati. I'm a programmer in PUI-PT Combinators and Graphs.
Okay. And then also we have Indah Lutfiatul Murshida. Also, she is a programmer, our programmer. Okay, please introduce. Yeah.
Good afternoon, everyone. My name is Indah Lutfiatul Murshida, and I'm also a programmer in Sigan, University of Jember.
Okay. And we have also machine learning and combinatorics. Yeah, young scientists. There is Anis here. Yeah, Nisvia Sari, please introduce yourself.
Hello everyone, my name is Rosanita Nisviasari.
Okay. Yeah, okay. And then also Ika Melissa. Okay, please introduce yourself.
Hello everyone, good afternoon. My name is Ika Nurmailisa and I working in mathematical education.
Yeah. And then Excelsa Suli Widatul Jannah. Okay, please introduce yourself. Yeah.
Thank you. Hello, everyone. My name is Excelsa Sulibildatul Jannah, but everyone call me Excel, and I am working in graph leveling.
Okay. Yeah, that's from my side, Professor Sundar. Maybe you can also introduce, because afterward, maybe it is better to like have a WhatsApp group if you don't mind, and then we will have a very flexible communication and discussion then. Yeah. Okay, that's from me. Please, brother, Professor,
Yes,
it's your turn to
yes, brother.
introduce your colleges or your student. Yes.
Yeah, good morning to all the Indians and good afternoon to all the Indonesian collaborators. So very important meeting for our international collaboration. So this is the first initiative from India and Indonesia regarding the postdoctoral program. So let me introduce my team. Co-supervisor Professor Dr. Shivashankar is also there. So he's a well-known person, good researcher from India. Then research scholars from India, Dr. Shyam, Uday Shri Karkala, Dr. Rasmi, and one more researcher from Saudi Arabia, Dr. Fatimatul Regina. So they all started their research work. Now, one by one, they will present their research. And also happy to see all the officials from Indonesia, Dr. Ika Hesti, Exila, and I always welcome you for India visit. Okay. So already, brother, I have created the WhatsApp group for this postdoctoral program. Once finish this meeting, I will add you and your team members in this WhatsApp group. We can have a brief discussion and collaboration in the smooth communication in the WhatsApp group. Okay. So now I welcome Dr. Shivashankar can put some word.
Very good morning to all. Very good afternoon to all Indonesian collaborators. So first of all, we would like to thank to the team of Dr. Daufik from University of Jember. Thank you, sir. Thank you for accepting this international postdoctoral program. It is very useful to the both the scholar and supervisors. It's an international collaboration also. Once again, I would like to thank to your university and then your team. So you have done a very good work. Then you came with your team, the entire team. So I would like to thank all your team members. So we are welcoming you all to India whenever it is possible. So we are also willing to visit your campus, and then we can get some more insight on your campus and then your lab also. So, and I would like to welcome all our scholars, all the scholars to this program. Four scholars right now they have joined. Few more are they are going to join very soon. Thank you. Once again, thank you. We can go ahead with immediately with the positive response. We will expect a good result from this program. Thank you.
Yes. Brother, can we invite the scholar to present? Okay. So, scholars, Dr. Fatimatul Rajana, can you introduce about you?
Yes, brother. We are ready now.
Yeah.
So
Yes.
our session today, I would like to all of you from the postgraduate research student to present your plan or your topic in brief, of course, not in detail, like 10 minutes for presentation. Either you are ready with slide presentation is okay. If you are not ready, no problem. You are welcome as well. And 5 minutes for discussion. So for each of you will share by what a moderator. So I asked previously Dr. Ika to share one of the what our postgraduate research student here. Okay, please, Ika, to share one of them. Yeah. Okay, to start with. Yeah, either Fatima Rajin. I'm sorry, brother. Here we have a co-supervisor. Am I right?
Yeah.
Uh,
Dr. Shivashankar.
Subra.
Dr.
Sure,
Shivashankar
sir.
Subramanian.
Sure, sir. Yes, sir.
Shiva. Okay,
Sure,
sorry. I didn't
sir.
mention your
Hello,
name
sir.
yet. Sorry about that. Yeah. Okay, Dr. Rika, please. Yeah. Okay.
Good morning, everyone. I'm Fatmatul Regina, and thank you for giving me this opportunity to do the postdoctoral research. C- Let me share my slides, Doctor.
Yes, you can, sir.
Please, Anis.
Yes, sir. You can share your presentation, ma'am.
Can you see it, sir?
Yes, we can see.
Okay. So, once again, let me thank you for this opportunity. And my research topic improved brain tumor diagnosis through multimodal image fusion and SWAM optimized deep learning framework. This is what I'm going to talk about on this presentation. Now, about me as a scholar, I have got 16 plus years of teaching experience and research experience. Currently, I work as a lecturer at King Faisal University, Saudi Arabia, and I'm the department coordinator since 2014, and I work as a member of accreditation and strategic planning committee as well. I contributed to different journals, Corpus Interest and Web of Science journals, and have a scholar index of H index of 10. Now, the research areas which where my interest is on AI-driven diagnostics, some optimization models, then healthcare informatics. These are my some of my areas of interest. Now, the research topic which is mentioned over here is an extension of my work on PhD, which I did at Anna University. Now, talking about the abstract of this uh, research. Here it is detecting the brain tumor presents a significant clinical challenge due to its heterogeneous nature and inherent complexity of multimodal MRI data. So here I'm trying to propose an computer-aided diagnostic framework which will integrate a novel multimodal image fusion technique, then deep learning feature extraction and optimization technique using SOM optimization algorithms for feature selection. So the motivation is traditional diagnostic tools often fail to interpret the complex brain tumor data reliably. So the need for a robust automated solution that can help from diverse image sources and optimize the critical diagnosis parameters. So, and also the motivation is to have a convergence of AI and bioimaging for having a transformative opportunity. Now, the main objective, as mentioned, like is to design a computational framework enhancing the tumor region clarity through the novel fusion of multimodal images, then extracting the meaningful patterns using adaptive deep learning models, employing the biologically inspired optimization for focused classification. So here is a small general framework which I propose, and detailed algorithms or detailed framework is not yet ready. Just thinking about, so the multimodal images which are collected from different data set, available data set,
I'm
and
sorry,
then
ma'am. Sorry,
yes,
ma'am. We cannot see the slide. We only see the first slide of your presentation.
can you see it now?
Yes, we can see it.
I'm not sure what was the
Make
problem.
it slideshow. Uh,
No, it was on Zoom, sir. I'm
Yes,
not sure.
it's okay,
please
ma'am.
press the slideshow button. Yeah, slideshow button.
Yeah, it's on slideshow. Can you?
So in the taskbar, in the bottom, in the downside, there is a taskbar. There is a slideshow button. Yeah, yeah. No, yeah, no, just a
This is not
little bit. Yeah, that's
slideshow,
one. Yeah.
but it is, sir. I have been showing it. I can see it on my screen, sir. I'm not sure what's
Oh,
the issue.
okay.
Now, is it visible, doctor?
Yes, it is
Yes,
visible, madam. It is visible.
visible, but
Please go ahead. Please go
okay,
ahead.
okay. Just keep on. Go on. Yeah.
Uh,
Please go
Okay,
ahead.
sir. Now, this is the proposed framework. Just a vague idea on the framework which I thought of. Like it's multimodal images which are collected from different data sets. These images are fused under some fusion techniques, uh, and then we use deep learning extraction on the fused images, and applying the SOM optimization algorithm for feature selection and a classification to classify the image as if it has a tumor or non-tumorous. The expected outcome is to improve the tumor visibility in the fused image, better accuracy, sensitivity, and specificity on the classification, reliable decision support system for radiologists, and integration of fusion by the end. The integration of the fusion, deep learning, and swap optimization algorithm. The validation, it can be done on the Harvard Medical data set, which contains registered images of CT and MRI images. And we can even try Brat's data set. Then here the matrix is precision recall, F1 score, AOC. This metrics will be evaluated, and then the benchmarked against certain state of art models, restless models, and different models. Then in future we can extend this framework to other im- parts like to lung, liver, breast imaging task. uh, Now recently I have a published paper in mathematics MDPI for breast cancer detection using flea algorithm, an enhanced version of that. So now again, for same way we have here, we can have the comparative studies with the particle SOAM and genetic algorithms, then integration of those things with the federated learning for distributed clinical data sets. Finally, the conclusion, the proposed research will bring together advanced imaging, intelligent optimization, and deep learning to address a clinical challenge, emphasizes innovation, scalability, and practical healthcare values. So, acknowledgement, thanks to all these advisors and for the institutional support, sir. And I'm here to listen to your suggestions. Thank you.
Thank you, madam.
Yeah.
So, question,
Yes,
Wika,
sir.
Wika bisa mempersilakan. Yeah, it is not
we
visible too much to
have
me because the slideshow was not working, but I see some image data in your slide presentation.
Yes.
How do you get the data? It is what data set provider, or you can or you use some what devices to collect the data?
Uh, I did not get your question, doctor.
Sorry, you can.
I did not get your question, doctor.
Okay, okay. How do you generate? How do you get the data, the image data?
Uh, Sir, the data set is available on Kaggle
Okay. From
and on
Kaggle.
GitHub.
From Kaggle, yeah.
GitHub for medical, the Harvard medical data set, it's available on GitHub.
Yeah, yeah, yeah. Okay,
GitHub.
okay. I understand now. Because normally we have data from Kaggle, and then we can do classification from Kaggle as well. And so the main target of your research, do you
To,
just consider the classification at the end, or also you would like to compare the effectiveness between one method to other method? Fatima?
definitely, sir. There will be comparison made at the end to in order to show that my work has achieved this accuracy or is better than the other one.
Okay, okay. Yes, because we have a lot of cases when we are trying to compare, yeah, the method, and some reviewer of the journal suggests it should compete with the published methods or with the methods which is already published.
Yes, doctor, I know that.
Yeah, so then if we have got a new result which is better than the previous one, then it is quite challenging. But sometimes published paper, yeah, they don't give us the coding, yeah. And then
No, doc.
we couldn't sometimes believe and convince that that is the best thing, the best result that they got so far. So when we run our method, sometimes it couldn't achieve the existing new result. Yeah. So,
No,
Dr. Fali, could you give us a little bit comment before you have a meeting about the experience, how to what challenging it is to compete the result with the what previous publication paper, which is giving a good results already. Do you hear me?
Sorry, what was the question again?
Yeah. So if you have a new paper, normally the results should be compared with the existing publication paper. But unfortunately, we couldn't have a coding from them. Then we couldn't run whether it is what right or not, that the results already attain the best value of the result. And people say, this is my achievement, and then they try to put some very, very high result, and then our new program couldn't beat them. So what do you think?
I think normally people, while doing comparison with the previous method, or we call it state-of-the-art method, people try to find the source code of it, but we need to be selective, which is we try to find it from the good venue of publication and try to find the GitHub page from them. But if they don't provide it, then we can just leave the paper and just select the one that provide the source codes. And we can just try to compare with them.
I
Yeah.
have a point, doctor. Doctor, can you hear
Yes.
me?
Yes. Yes. Yeah. Please.
Now in high index journals, they don't publish things which does not support with the code. If we have found, we can see that the code is available. They say either you can email the author or it is on GitHub. So there are now restrictions for high index journals that without code they don't accept it. Like for example, plus one.
Yeah.
Then
Yeah.
for mathematics, which I recently said, like all those Q1, Q2 journals, they are in need of this.
Okay. Okay. Yeah. Very good. Very good. Yes. Yes. So you said that if we submit to a good journal, either it is Q1 journal or top tier journal, they requires to submit a code as well. Otherwise, they will reject. Yeah, they will reject our submission.
Yes, this is the recent
That
policies,
is good.
doctor.
That is good. Yes, yes. Okay, okay. Understand, understand. So if we can get this, and then if we can send an email to the author, then the author can send the email to us. Then we can run, and then we also run our new result. Then finally, it will be easier then to get the comparison between the existing result and the other result. I believe this is all the issues of the computer science normally. The comparison, because the table of the effectiveness of the result is not analytical solution. It is a little bit different with the mathematics. In mathematics, because it is analytical solution, then we can track the what the proof. For example, we can track the lemma, we can track the theorem by means of the mathematical principle. But in this case, I also suggest maybe it will be better also if we can do a Blasan study. So, and then we can open the black box of the code of the model also, and then maybe we can do a little bit analytical solution about this one. So hopefully, but otherwise, your presentation is nice, your plan is very good, your proposal is good, and then hopefully we can deal with this proposal effectively for the future. Thank you, Fatima Rajan. Thank you very much. Yes.
Thank you, sir.
Dr. Sundar, do you have any comment or?
No comments, brother.
Yes, yes.
We can proceed to the next one. Dr.
Yeah,
Rashmi, are you there?
Yes,
Dr.
sir.
Yeah,
Yes.
yeah, please proceed.
Okay. Okay, sir. Now I'm sharing my screen. Is it clear, sir?
Yes, it is visible. You can
Hello.
proceed.
Okay.
Yes, it is visible. You can
Okay,
proceed.
sir.
You can proceed.
Okay, sir. Okay. Good afternoon, sir. I'm myself, Rasmi. I'm working as an associate professor in information science and engineering. I have more than 16 years of experience in teaching and research. I have already published more than 20 articles in reputed journals and 7 patents also. So my work is a multi-tier learning model for segmenting cardiac imaging magnetic resonance. So this is my topic. So abstract. Here the deep learning models we are using for the segmentation. So this work mainly concentrate on modeling an efficient multi-tier learning approach for segmenting. So this proposed model, it adopts a convolutional neural network model for segmentation, and also it is an integration of 2D and 3D representation. So this model, the proposed model, which gives better prediction accuracy than the existing methods. So here problem statement. So the cardiac magnetic resonant imaging, it is a standard for determining the volume and weight of the cardiac chamber in a variety of cardiovascular disorders. So here different methods are there. So the manual segmentation, everything, it is time consuming. Also, it is error prone. So because of this existing approaches, this has some limitations. So we need some accuracy in the segmentation. So that is the problem statement. Then proposed solution. Here to solve the existing drawbacks, a multi-tier deep learning network we are proposing. Also here we are using a 2D network with 3D. Also the suggested workflow, it is very much helpful for segmenting CMR images. So these are the proposed methods. So expected outcome. So here the pipeline will generate the exact shape, prior information, enabling smooth, precise, and it also overcome the drawbacks of the existing methods and all. So these are the outcomes. So these are future extensions of this work. So future models can integrate data from other imaging techniques like CT, PET scan, and ultrasound, like that. So these are the future work of this. So this study, so can I conclude like this? That is, this presents a completely automated workflow for shape-based segmentation of CMR. So here we suggest a novel network. So using this, we can give a clear and more accurate segmentation and localization methods. So this merges the 2D network's computational speed with the capacity to solve the 3D dimensional spatial difficulties. Also, it improves the performance by integrating these two, 2D and 3D. Thank you, sir.
Thank you, madam.
Hello.
Yeah.
Yes, thank you, madam. Thank you, madam.
Thank you. Any
Okay,
queries?
thank you, sir. Thank you.
Any queries from Professor?
Professor Dopik sir, Professor Excelsa ma'am, you have any queries? Do you have any more queries?
Yes. Okay. Yeah, I just discussed with my staff just now. Because all of you, both of you, Rashmi and also Fatima, dealing with the image. Yeah, image. So my student, my staff will ask something to you about this project. Silakan, Mas Rifki. Tidak apa-apa pakai bahasa Indonesia atau bahasa Inggris. Silakan, ya.
Yes, sir.
Yes, sir. You have any more queries?
Before pertama tadi
pakai bahasa Indonesia aja.
Miss
Pakai bahasa
Fatima.
Indonesia aja.
Oh iya, Bro. Jadi untuk Bu Fatima, tadi kan di presentasinya menggunakan algoritma particle swap optimization untuk mengoptimasi parameter dari CNN-nya. Nah, itu apa pertimbangan dibalik penggunaan algoritma optimasi PSO sedangkan saat ini?
Artikel swarm optimization, ya.
Iya, Bro.
Itu yang Fatima. Fatima
iya.
Already presented about using apa tadi? Swarm
optimization.
Swarm optimization. In fact, we already know that then swarm optimization is already quite old-fashioned model that we already when we are using in machine learning, especially for the classification. And I believe also the model that you already use for multi-tier learning model or anything, it already exists in the some publication in there. So will it be optimistic that we can have a novel of the result of this work in the future? What do you think? Yeah. Yeah, please, Rashmi or Fatima give also a comment. This is brainstorming such that we will understand each other, our work in the future. Yeah.
Brother Fatimatul
Yes.
Regina, she's having some meeting, so she left it.
Ah, okay, okay, no problem, no problem. Yeah.
Okay.
There
Dr.
might be
Rashmi, do you
also.
have any comments regarding this?
Hello.
Yeah.
Yes,
Do you
yes,
have any?
yes. Yes.
Yeah. Do you have any comment about the swarm optimization techniques? Whether it will be useful
No,
for your?
sir, because I'm not using this SWAM optimization technique, sir.
No, no, no. Yeah, actually, that's actually all one of the example. So what I'm thinking now, do you use a new model that you modify by yourself, or you use existing model, just like in this case,
No.
multi-tier learning model, for example?
Yes, sir. This is a new one only, sir.
This
Not
is
an
a new
existing
one.
model. Yes, sir. Yeah. For
Okay.
this proposal, we are suggesting a new one. Based on the existing only, we are giving some modifications. Based upon that only, we are
Okay,
framing
okay.
a new one.
So
Yes,
new
sir.
ones people already publish, and then you will modify in the future, or what do you think?
Yes, sir. It's a
Okay, okay.
modification only.
Yeah, yes.
Okay, sir. Thank you.
Yes, 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 yes. Okay, okay. Because now with the, I believe Professor Sundar already now, with the existence of the data sets provider, sometimes they also give the data set as well as the code, and then we modify. But when we modify and then we follow and we include the mathematical or analytical analysis in it, maybe in the future it will be very nice, since
Yes, sir.
modification of the coding sometime it is not in the paper, it is not in the code. However, we do not include the code in the paper, but maybe yes, the managing editor will require about the code, but sometimes we do not. So we do not, as the reader, they don't understand what they already improve in the paper. So maybe this is the challenge for the future in our collaboration. Okay, that's, but
Okay,
otherwise
sir.
it's very nice, but it's also notifying me that you are also working on the image, cardiac image. Yes, yes. Thank you, thank you,
Yes, sir.
thank
Okay.
you.
Thank you,
Okay,
sir.
yeah,
Thank you very much.
please keep going, Professor Sundar. Yeah.
Yes, yes, brother. So shall we go for the
Next,
next presentation?
Udayashree, madam.
Yeah, sir, I'm ready, sir.
Yes. Yes, you can proceed, madam.
Yes, I'm sharing my screen, sir.
Please share your screen, madam.
Is my screen visible, sir?
No.
Yeah.
Just please give the option of sharing this screen, sir.
Not visible.
Ma'am, anyone can...
Can share. Sharing with laptop?
No, yeah, sir. I'm along with my laptop only. Share screen. Yes. Now, sir. Yeah, sir, now?
Yes, ma'am.
So now it is visible,
Yes,
visible. Now it is visible.
Visible, sir? Okay.
Please proceed, please proceed.
Yes, visible.
Yes, visible, yes, visible.
Good morning to all the professors and all the scholars at the university. I'm Udayasri Kakarla, working as an associate professor from the Department of Mechanical Engineering in KG Reddy College of Engineering and Technology. It's in Telangana state, India. I'm very honored to work under the guidance of Rafik sir as well as Sundar sir and Shivshankar sir. And coming to this presentation, I'll be presenting. Can you see the change of slide now? Yeah. Now coming to this
Yes.
presentation, I'll be sharing about my introduction and what is my research proposal, abstract, the problem statement, and what I'm thinking about the solution would be might be the better solution, and what are the outcomes of implementing the solution, and what are the future discussions. And coming to me, I have a 20 plus years of teaching experience in the Department of Mechanical Engineering, and have 5 patents, and even I'm the founder of RUA Private Limited. It's a startup. And coming to this accreditation parts and all, I'm the convener of a NAC accreditation committee in the year 2017. And moving on, working with the NBA accreditation process and head the Department of Mechanical Engineering. And now, as of now, I'm working as a Dean Department of Student Affairs. And published my many of the papers in the Scoopers Indexed, along with my research work and regular research work that happens along with my students in the campus. With this brief introduction of mine, let me go ahead with the title. What I want to do is advanced engineering technology for AI driven condition monitoring of VCR engine for its performance, emissions, and smoke by using the alternate fuel. Like alternate fuel is of a biodiesel along with the hydrogen gas. Am I audible, ma'am? Sir, am I audible, sir?
Yes, you are audible. You can proceed. Yes, you are
Yeah.
audible. You are audible. Proceed.
Thank you, sir. And my objective is in order to align the experimental data that I have conducted during my doctoral program, I want to compare that data set that what I have manually that we have collected during the experiment to be more aligned with the AI in this postdoctoral program. And here I've taken the biodiesel from flax seeds, and we have a combination of like a B10, B20, B30, B40, B50, along with the combinations of hydrogen gas from starting from 5 lpm to 15 lpm. What sets of combination will give you a better result for its performance of an engine, either for the less emissions and the less smoke. During the experimental setup that what we had during our research program, like we had an VCR engine, which is an aligned with the smoke detector as well as the emissions. And we have gone for this validation of the vibrations also by using LDV, laser Doppler vibrometer, where we can directly get the graphs of displacement, the frequency and the velocity at the different data sets that we have set up for the experimental data. And that all has been calculated by using the mathematical relations, and by during doing this RSS method, surface regression methods, and we have plotted the graphs, and that was submitted as a PhD work. And addition to this, whatever we have done for the PhD work, that I'm trying to give the prompt to the AI, where I want to compare the experimental data, which is conventional, And this is the data where I can go for iterations and compare the results where I can get more accurately. This is what I'm expecting to do in my postdoc. And what is I'm trying to add, include AI into this by, like, one is the CNN, by using the CNN, and by using the modeling sets with the LSTM, and the fuel blend optimizations with genetic algorithm, and real-time fuel adjustment. Like, if I go with an experimental data, there's a option for where we can change the compression ratios, the fuel blends, and the loads as well. As per that, as per the results, we can readjust the which is optimal fuel, real-time fuel adjustment, so that I can get a more efficiency with less smokes and the emissions. And by doing all this, what is my outcome of this work is, like, to have an optimized fuel blend and reduction in the emissions, and the scalability of the data set, that what I've started doing the experiment in the VCR engine. And really, in reality, like, how far I can go for the adaptability at the particular combinations for a better performance, and for low emissions and the smoke. And the future, still we can go ahead by having this AI model enhancement and fuel tech innovations. If anything, like, not only one fuel or the biodiesel, just we can go with the multiple type of biodiesels. And even we can go with the change of the gas as well. Like, right now I'm using the combination of biodiesel with a hydrogen. Now I can go ahead with a CNG. We can do the multiple fuel blends that we can do it. And if we get a better results, that also we can go for the commercialization of the blends that can be used in any of our automobile sector. And keeping all this in mind, like, global warming and all will be minimized by choosing, instead of the conventional fuels, diverting that to a biodiesel, where we can come up with a less or the low levels of emissions. And this is the conclusion of my expectation from this postdoctoral program, along with the research program that what we have done, and aligned with the emerging technologies, so that what are the best results we can observe and we can get it. This is the part from my end. Just please share your comments on this.
Yes, Carla, thank you very
Yes, sir.
much. Very nice. Can I give you some comment or question? Yeah. Udah ya, Kak Carla. Yeah.
Yes,
It is yeah, okay. When you are talking about AI, this is the end, the last stage of the machine learning, because subdomain of AI is machine learning, subdomain of machine learning, artificial neural networks.
yes, sir.
Normally, in our case, if people talking about AI, at least they already deploy the code into devices. For example, in my research group, there is a robotic research group.
Yes, sir.
We are working with them. We are developing a wheelchair for the disabled people. And then we are working in coding in my mathematical side.
Yes, sir.
We are trying to find out the effective code and everything. And then we do not consider it is AI. But when we deploy the code into a chipset, and then we put the chipset in the wheelchair, for example, then it is already AI. So what do you think? So is your research will go there? Will your research go to further to the end stage of the machine learning, or you actually only do a simulation by using
Just
by
we'll go
running a
with the
programming? Yes, please.
we'll go ahead along with the machine learning side instead of AI like that.
Yeah, that's my question. So will you go with the developing a prototype, for example, and like using
Sir,
developing a sensor with a smart sensor which is equipped by machine learning that we call this, it is actually AI. Will you go until this side, your research?
sir, coming to this prototype, already there are research laboratories where they have a setup of VCR engines, a variable compression ratio engine,
Yeah,
aligned
yeah.
with a system where when we run the machine engine, then it gives the data sets. Like for example, like if I take the combination of B10 plus 5 LPM of hydrogen, B10 means like 10%, 100%, 100 ml of biodiesel and 900 ml of diesel. For example, I'm giving a sample. B10 plus 5 LPM of hydrogen, I'll be giving that, feeding that to the engine. When it
Okay,
runs
okay.
at a certain loads of 2 kg load, 4 kg load, 5 kg load, 10 kg load, like there's a restriction of around 12 kgs, maximum of 12 kg. It's a static VCR engine, sir, in a
Yeah, yeah.
research lab. And we give the different types of blends of fuel.
Yes,
And
yes.
that, when we run the machine at particular speed of 1500 RPM, by giving a inlet pressures of like 120, 130, by varying it also, like we can get the different types of data. And by having the data, we can calculate the efficiency, engine performance, like volumetric efficiency we can find. We can find the performance of an engine. Along with the performance of an engine, two devices, one is a smoke detector and the other one is the emission detectors, where in the emission we'll get the hydrocarbon particles, unbound particles composition, and the nitrogen or the carbon monoxide, and we'll get the values within the kit. And coming to the smoke equipment, we have a like opacity, like what is the clarity of the smoke, like how much smog we have, the smoke that is being released by the by the engine after doing the experiment. And along with this, we have conducted one condition monitoring by using a laser Doppler vibrometer, sir. And where we have a graph that can give the frequency of the vibrations of the engine when we run the engine at that particular blend. This is a biodiesel combination with a hydrogen. That we have done, and we have come up with the data and with the mathematical relations of the formulas what we have. With that, we have frame an Excel and we run that in Power BI to get the sample range of which is giving us a better. That is my research part, sir. And now coming to this postdoc, if I can, as I have the data set with me manually, which was done, and that I can do it with a machine learning. If I can compare these two results and see that like which is giving a better opportunity, a better manually, I may be doing some miscalculations. When it is fed to an emerging technology, if that is giving a better result, that these two results can be compared and we can give a comparison results in this program. So that is my expectation. Whether I'm right or wrong, I doesn't know. Just that is my thought process, sir. Just please suggest me what would be the best.
Yeah, yeah. Okay, that's very good. But what I'm thinking is, how do you get the emissions, smoke or carbon monoxide or hydrogen
Hydrogen oxides and all.
data? Is it from Kegel or from a sensor?
Yes,
From
it's like exit of a engine will be connected to the device, sir. This emission device, emission kit. I'll share it. I have the pics also, sir. While doing the experiment, I'll share it so that we can have a clarity on where the smoke devices are connected and the emissions devices are connected. Where
yeah,
the exhaust gases will be connected to this smoke devices, smoke or emissions. Then with the exhaust that is coming out of the as an emission, will give the percentage of emissions like
yeah.
carbon
Okay,
dioxide.
understand. So, in conclusion, that you will derive or generate the data from the primary devices.
Yes, sir.
Ah,
True.
good. Not from Kaggle and from everything. Yeah, not from data sets providers.
No, no,
So
no.
you already have like a sensor or smoke sensor or emission sensor or everything in the laboratorium, or because also we have a sensor like humidity
Yes.
sensor, temperature sensor.
Yes, sir.
We instead having a data from Kaggle, normally we use a streaming data from a sensor.
Yes,
Yeah,
sir.
but still, actually, it is not AI. Actually, if we just do a simulation about the data,
Hmm.
and then we try to find out, for example, to forecast the data, what happened doing a multi-step forecasting. If we uh, takes the data for a certain period, for example, for a month, and then we will predict what happened, the emission content, smoke content, hydrogen content for the following 3 months, for example, using a machine learning. So
Yes.
that's might be your aim in your research. What do you think?
Yes, sir. It would be good, sir.
Ah, okay,
Whatever you
okay.
suggested.
Yes. I understand then. But it is very nice because you generate data not from Kaggle, because Kaggle sometimes untrustworthy, sometimes it's not yeah, we need to normalize sometime, yeah. Okay, but it is okay. It is okay then. Okay, Kak Carla. Thank you very much. Very nice. Yeah. Okay, thank you.
Thank
Yeah.
you, sir. Sir, I have a small question, like
Yes.
firing.
Okay, Professor. Yes.
Is there any opportunity for us to come down to the university as you people are having you people are also traveling with some researchers?
Oh, okay. Yes.
Is there any scope, sir?
Yes, yeah. So are you under Faculty of Engineering or under Faculty of Computer Science?
No, sir. I'm from the Department of Mechanical Engineering.
Oh, mechanic. That's very good. Yeah. Understand then.
Ma'am,
Understand. Yeah.
yes, we can visit, madam. Yes, we can visit. Once your work started, it is progress to the next level, we can visit. We will plan
Yeah,
for a
sir.
Yeah,
visit
Like,
yeah.
also.
why
We will
my
plan
concern is like if we can collaborate and do the work over there also for a few months, just we
we
can
can
share the
we can
knowledge
visit
that what we are.
we can visit and we can see the labs and we can the staying and working there for a month. I don't know whether it is possible or not. That is relevant to computer. That is they are completely relevant to the mathematics. Yours is completely mechanical. It's interdisciplinary research we are doing now. We can visit the lab. We can visit the lab. Once we can visit the lab. This is interdisciplinary research. It is not on purely computer science or purely mechanical or
Yeah,
purely
yeah,
mathematical. It is
yeah, sir.
interdisciplinary. So we can visit and we can discuss with them. Then we can come back. As like as how we are doing for the international postdoc programs. We will
Yeah,
let
sir.
you know when we are planning for the trip. Mostly it will be on after July or August. We are planning. We will let you
Yeah,
know once the plan is confirmed.
sure, sir. Thank you, sir.
Okay.
Thank you so
Okay,
much.
ma'am.
That's very good. Yes. Okay.
Thank you.
Thank you. for yes. Okay, the
Shyam, next Shyam. Hello, sir, Shyam.
Yes, sir, I'm ready, sir.
Yes, sir, you can proceed.
I'm not able to share. Can you give the
yeah.
permission?
Yes, you can share.
Anis,
Madam
yeah.
Sagarna, madam, you can ma'am, you can disconnect yours.
Please stop share for.
Udayshri, ma'am, you can
Yeah,
disconnect.
yeah, ma'am.
Yes, now
You
you can
can
share,
share.
sir. Now you can share.
Sure, sir, sure. I'm sharing. Is it visible?
Yes, it is visible. So
Okay. So, good afternoon, everyone. So, probably it's been a long session for everyone. So, I'll just introduce the topic what I'm gonna handle with. So, I have taken up a topic called as quantum theory-based hybrid model, which allows us to detect the intrusion using textual data. So, before going into this, let me introduce myself. I'm Dr. Sham, and I have been working in the field of education for almost like 15 years right now. Currently working with the Presidency College and Presidency University, which is situated in Bangalore, India. And major research focus was on emphasizing the machine learning encryption based techniques to detect the intrusion. So, threat detection was my doctorate component, and now I want to increase the level of competency and improve my existing work, what I have done in my doctorate, and I have to complete my. I'm thinking of going ahead with quantum computing for the same process. So I also have two patents, which is already being sold in the market. For one is the medical device cybersecurity, which allows us to. Many of you people will be having the smart watch. Over there, we have the heart disease, as a heart rate calculator. So no one can tamper this thing if we use this one. So we have a group of 10 members. We had this patent done, and we also have a contract with the Apple iPhones and Apple smartwatches for this particular patent. And I have been certified as a search engine optimizer for from the Google. And the next thing, the research what I'm proposing today is based on the threat detection. Means in recent days we have come across a lot of things where everything goes online, and each and every information what we are sharing with everyone is not considered to be the genuine one. So most of the times we get caught into some sort of attacks or anything. You may lose your data, all these things. How can we protect ourselves in the era of quantum computing? Nowadays, even the AES algorithm and any sort of cryptography can be broken out using the process of quantum computing. So, how do you avoid it? So, incorporating the quantum process into your classical method can generate a better way of intrusion detection. So my problem statement will be what is the existing thing and what are the problems that we are facing in the existing components. The existing thing is like we are finding out by malware description and incident logs. Means if a company has faced any sort of attacks on them, they will be having a logs. So that logs we are taking and malware description we are taking. So how can and we are using NLP for linguistic process. And what are the major problems that we are facing in the existing statement? That is classes imbalance, okay, where we do not have, which leads to the higher false negative process for false negative data, and model fragility. The model is not capable of handling larger loads. Means if you a person is trying to attack on you, and if he is giving you a blackout process, then if he nukes you, it's not possible to handle the whole process. And the next component is what is my motivation? I have taken three major components which we can consider as a research gap also. Improving the feature of expensiveness means right now we have a lot of information which is in the market, and a lot of softwares which are coming right now says that we are providing quantum based techniques to give alerts. They are not protecting us. So if you see Kaspersky or anything, they are not protecting us. They give us the alerts. So my method will provide us a proper protection where it detects each and every information which is coming inside your computer and finds it out. Now, the second concern comes into picture where we say that, okay, the data is confidential. How will you check it? So whatever data is coming inside, every data is encrypted. So we'll be having three different layers. One which is working in the classical method, classical dense layer will be used, and second one will be the quantum inspired layer. Am I audible? Is everything fine right now? Hello?
Yeah, it's okay. Proceed.
Yes, sir,
Samson.
yes, sir, you can proceed. You can proceed. It is very nice. You can proceed.
Okay.
Yes, please.
So
It's fine.
the input right now, the inputs what we are going to take over here is a simple thing. Let us consider an example of our day-to-day email. Once we send an email, we will be having our IP address, email header, and the keywords which is present inside it. So which is considered to be a confidential information for one particular person. Now, any third party cannot look into the personal emails. So what our software will do is it will take it, it will encrypt in such a format that it will not be visible for the third party persons, like how the database administrator does. Now, if the database administrator had the ability to handle all the bank details, then obviously he can transfer each and every account's money into his own account and he can vanish. So same concept over here we are utilizing, and we are not gonna give the details to the person who is finding out the errors. What we are gonna do is we are gonna use PCA and SMART method to scrutinize the data and information whatever is available. After this, what we are gonna do is we are gonna consider dual path. In this dual path, we will be having neural network layer for classical method, and then we will be encrypting for the quantum path. This quantum path itself is a huge topic, and my topic over here is whenever the information comes to me, I will encrypt and use a fixed rotation process, which is also called as an orthonormal transformation. By using trigonometric functions like sine and cosine, they have a particular wavelengths. So whatever encryption is done, this particular wavelength will be given to the encryptions. So whenever a malware comes into the system, the wavelength changes. So obviously I can detect that that particular wavelength is not of the data which is required to this particular system. So I will categorize that into a malware. Now this can be a promotional email also. So to check that, what I will do is I will take that unwanted sine wave which is being provided, that will be checked with the existing data set of malwares. If the malware gets combined, if we have a clear picture that it is a malware, then we will discard the email, or else we will alert the person who is getting the email as a phishing email, or else we will send it to this thing. Now, to detect this anomaly, I'm again using two different process. The first one is isolation forest. In this isolation forest method, what we are going to do is we are going to spot the unusual emails, like what I said, the wavelength of that particular thing may change. The malware will change. So it will spot it out using isolation forest. And the next detail is I'm applying a random forest method where the classifications of the email based on the learning process means previously if same type of emails have come, what was the cautions that were taken. so that it reduces the time of the whole process at a period of time. Means if same malware is being attacked on that particular system, previously if it has seen, it will directly discard it. It will not go through the whole process. This actually reduces my time, and it actually reduces, it gives the optimization very well. So the summary of this whole thing is, I'll get an input. In that, I'll use PCA to scrutinize the data, and Smart, because phishing emails may be very rare. So what Smart does is, it will generate a synthetic data which always acts as a false information. So it will give you a clear picture of this thing. Then the dual path contains of a classical method and a quantum method, which is then fused together and sent into my isolation forest and random forest. And finally, the output will be whether the email has to be considered as a phishing email or else a genuine email. This is the whole process. And for the training accuracy, I'm expecting it to go more than 95% when compared to the traditional model, that is the previous model. And validation accuracy is also considered to be expected to be 95% and above. So this is what we will be expecting, and the conclusion and the future framework, future works is like integrating this with the real-time cybersecurity incident responses. Like if you are sending a email, this was a basic things. What if the data has been channelized? Several defense informations which is being transmitted over internet. If someone intercept that, how can I avoid this thing? All these can be done using this thing. But everything over here is based on theoretical process, and I have used GPUs and TPUs of Google's, which Google which is renting itself. So by that, I have almost achieved 92% right now. And the data set what I have used is from York University. One minute. York University. This is York University dataset, which consists of 70 million data and 15 different streams and 25 segmentation under it. So the computational power is required is huge to accomplish this statement. Since Google is providing the ability to work on the servers, we can achieve this thing. And then uh, that's it from my side. We can, if you have, I'm open for the discussion right now.
Yes. Ah,
Thank you, Sham. It's a very nice presentation. Thank you.
thank you. Thank you, Sham.
Yes, sir.
Could I
It's very nice presentation.
Thank you, sir.
discuss something? Yes,
Sam,
Sham.
Yes, sir.
It is very interesting for me, and at the moment, I know about the computing, quantum computing.
Yes, sir.
And then you introduced to us about the quantum-based machine learning or whatever. So could you tell me a bit about the quantum computing and quantum-based machine learning? Do you combine the philosophy of a quantum computing work in the machine learning model?
Yes, sir. I'm combining actually in quantum computing. What I'm doing is I'm converting all the data what I'm getting into a sinusoidal wave, so that only sine wave and cosine waves enters into the system. And if the malware is coming inside the model. Over there only, I will say, when I convert it, it gives me the anomalies. If it is not the original data, it gives me the anomalies. So I'll discard
Okay,
it there only.
yeah. That's very good, doctor. It is very nice. So when you are running the code, do you use quantum computing, like you should subscribe or hire the server in the IBM, for example, and also in the Google and everything?
Yes, I'm working with Google, sir. Actually, once the previously I got the certifications done, and one of my friend is working in Google, so I get the subscription
Okay,
from the
okay.
Google.
Yeah,
So this is one of the things, and actually, I have worked on Kaggle data right now.
Mm-hmm.
And for that itself, it took computational hours, like 12 hours it took for the process,
Yeah,
the
yeah.
whole process. And the accuracy, what I have got, I can show you that. 1 minute. Uh, just let me share the screen once again.
Yeah.
Right. So this is the architecture what I have used, where I will be dividing it into two different parts. The input layer will be divided into two dense layer.
Yeah.
One will be processing with the quantum encryption, and the other one goes with the regular batches. And the finally, the dense layer applies on all the algorithm, concatenates it, and then my whole process gets filtered. And lastly, when it gets filtered, it gives me the final output, whether it is a
Okay.
phishing email or not. So
Yeah.
the training and validation ratio, what I have got over here is almost like 97% right
Oh,
now. I'm trying
fantastic.
to,
Yes, yes.
yeah, I'm trying to improve this thing. And this is the confusion metrics what I have got right now. It's like it's actually good what we have received. But as we said in the previous sessions, like we can't trust Kaggle's data or GitHub's data. So I have requested for a original data from York University. So
Yeah.
if
Okay,
they
okay,
provide
okay.
me with the university, it goes up to 70 lakh data, 70 million data inside it.
Mm.
So I hope that same computational process works on that also. So the training validation is already this, and PRC curve is wonderful. It's coming at 98.5%, and the ROC curve is also around 98.5%. So this is what I have done till now for the presentation. And right now, I'm just waiting for the original data set to arrive. Once I get the option of the original data set, I'll implement on that. And since it will be a
Yeah.
genuine new process, it's not done in the previously in any papers or any research. It's a new component which I am introducing into the market. Hope this gets patented or anything.
Yes.
Yeah. So is there
Very nice. Very nice.
if there is any feedbacks from your side, please let us know, sir.
Yeah. Definitely. We are working and learn together. And
Yes.
then, of course, uh, nice research uh, tends to be complex. Even we couldn't solve in the polynomial time, and then it will be done in the sometime long future and then sometime short future. But it's okay if, as long as we can collaborate with Azure, then we can contribute, each of us, to what perform our best research and novel research in the future. Yes, thank you very
Yeah.
much. And thank
Thank
you,
you, sir.
Dr. Shifa Shankar, also
Yes, yes.
already share this. Brother Sundar, you back now.
Thank you, sir.
Okay.
Thank you for Thank you for
Yes,
your
thank
patience.
you.
Thank
Sorry,
Dr.
a little bit. There is a back sound because
No
I
issues. No
forgot that I
issues.
have a class now.
Okay,
Already
okay.
finished. Yes,
Thank you,
sir.
sir. Thank you so much
Okay,
for
okay, Sundar. So
staying
once
with
we
us.
have already group, then we keep going, keep continue to step further our joint research in the future. Yeah, thank you, thank you,
Yes, brother.
Thank
Thank you
you.
so much.
thank you very much, thank you very much.
Yeah,
Yeah.
I will keep in touch with you, brother.
Yes,
Maybe.
yes. See you then. Bye bye. Yeah, see you sometime. Yeah,
Bye.
okay. Dr.
Thank you, everyone.
Shifa, Dr.
Thank
Sundar.
you.
Yeah, thank you. Hmm.